What's up, everybody? This is Standard 6, CSTs, Algebra 2. Okay, Standard 6 is students add, subtract, multiply, and divide complex numbers. Alright, so this is a pretty complicated standard, but if you get it, it's real easy to grasp. Right here, we have our first problem. We have to simplify this, which is what pretty much Standard 6 is all about. This one right here. 8 minus 4i over 5 plus 8i. And our job for this is to simplify. Now, for different standards, usually you can factor out some stuff. Like, say for example, if this was just here, right here, just 4 over 8i, it would come out to be a half I, because negative half I, because of the minus. But anyways, if it were like this, if it was just 4i over 8i, then you could factor it out to just be a half I, because the numbers would cancel out. But since we have these two extra ones right here, that means that we have to multiply it out farther. Anyways, in this case, we do 5 plus 8i, and we have to do the complex conjugate, and we have to multiply this same equation by the complex conjugate. To get the complex conjugate, you have to get this right here on the denominator, and you have to switch the sign. That's adding, subtracting, multiplying, dividing right here. Mostly adding and subtracting. So what we get is 5 minus 8i. See how it's 5 plus 8i? The complex conjugate of 5 plus 8i is 5 minus 8i. This rule applies to all of the complex conjugate types of things. So what you have to do is you have to put the complex conjugate both up and down, so you can factor it out. Now, instead of just times, we're like, oh, well, it cancels out. Well, just leave it like that for right now, because we're going to be multiplying these two out. So, what we get from this is 8 minus 4i times, 5 minus 8i. See how I got that? I multiplied that out right there. Down, and we get from this, just multiply it out. 5 plus 8i, 5 minus 8i. We're still multiplying these out because of the complex conjugate to simplify. Okay. Now we multiply these two out right here. What we get is 40 minus 64i squared minus 20i plus 32i squared. What you do right here is you FOIL it. Remember the old FOIL trick, first in, out, last? Yeah, that FOIL. And we put it under this same right here. This is a difference of squares, so if we factor that out, then we get 25 minus 64i squared, right there, like that. Sorry about that. So that's what we get. Now, as you can see, there's these three right here, or these two, negative 64i squared plus 32i squared. Now, if we factor those out in order and put the things in order, this is what I'd like to do. I don't know about you guys, but what I do is just combine like terms, and then I just put the exponents in order. Like, say for example, I put I squared first, then 20i, then I to the 0 power, or no I at all. Why do I do that? Honestly, I like to do it better. It doesn't really, mix up the thing, but I find it helpful though. I don't know about you guys, but if you find that helpful, then go ahead. By all means, put it in order, but if not, then no, just go ahead and keep going as you would in the classic method. Alright, so negative 32i squared minus 20i plus 40 over 25 64i squared. Now, as you can see up here, this can be factored out 4, right? A 4 can be factored out throughout all of these right here. So if you go like that, you get 4 over negative 8i, or times 8i, minus 5i plus 10 over 25 minus 64i squared. And that's your final answer. That's the simplified way to get from the complex conjugate to simplify this down to here. The complex conjugate always helps. I mean, it's like a basic for this kind of stuff. So this is how you get it. If you say, oh, well, let's factor this out right here, then you'll come back to this result right here. 5 plus 8i, 5 times 5 minus 5 plus 8i times 5 minus 8i. Excuse me. And then what'll happen is you'll keep going around in circles. This doesn't really help. I mean, if you want to factor it out, go ahead, by all means, go ahead and factor it still. But you know, I don't like to factor it out because I feel like I'm going in circles. But I like this answer better because it's a little bit more simplified than this. Okay. Now, the second problem that I have on my list is 6 over 10 minus root 6. Right? Simplify that. Due to the fact that the numerator is a number, is one single number, and the denominator has a root in it, makes it a little bit more easier. So if you find square roots in these types of problems, don't freak out, because it'll really just, lead you to like a panic attack, and we don't want that. So if you see a square root, don't freak out, no pressure, just don't freak out. Alright, so same thing as with what we did on top. I left this on the same page just for a quick reference, just in case. Complex conjugate, 10 plus 6, or root 6, excuse me. 10 plus root 6, you got that. Multiply it out, you get 6 times 10 plus root 6 over 100 plus what's the negative square root of 6 times the root of 6, none other than negative 6, right? Because if you times the square root of 6 by itself, then you get 6, right? It's a no-brainer. Anyways, so that's 100 minus 6. So what you get is 6 times 10 plus 6, or root 6, and you get 100 minus 6. Work that all out. You get 60 plus 6 root 6 over 94. Final answer. Alright, hope you found this helpful. As all fractions, use this in the real world for dividing, simplifying, as you can see by the standard. I'll say the standard again. Standard 6.0. Students add, subtract, multiply, and divide complex numbers. There we go. Multiplying, dividing, shows you all the basic steps for anything that you need in the workplace. Hopefully I found this helpful. There you go.